Exploring the unknown has been a challenge for explorers over the centuries. As the machines blaze a trail across the solar system, we can see the sun, moon, and planets with more clarity than ever. It is as though their cameras are our windows on an extraordinary journey. We can see the cosmos through their eyes. Thanks to the invention of spaceflight, we have access to a variety of alien worlds and new territories. The night sky has been a window to a larger reality since the dawn of humanity. According to our ancient ancestors, the heavens above were evidence of something beyond. They were inextricably linked to life on Earth. Our ancestors observed the sky night after night and year after year, wondering what those changes might foretell about their destiny. There were a few changes that were easily observed. Constellations drift from east to west, like the nightly drift of the constellations. This is like the lunar phases of the moon that march from east to west. In addition, there were more fleeting changes, like colourful aurora borealis displays. From our ancestors, no change attracted as much attention as the complex dance of a few sharp objects moving around among the constellations. Although they looked like stars, their motions made it clear they were not. In Greek, they were called planets or wanderers. Throughout history, astronomers have puzzled over the motions of these planets and attempted to understand how our universe works. We could not see how particular the planets are without the invention of the telescope. When the telescope arrived, it opened up a whole new view of the universe, transforming the planets into distant worlds orbiting around the sun from just lights moving in the sky. It helped us understand that we are part of a solar system full of planets, asteroids, comets, and more. Any telescope can only show us a limited amount of the solar system. What happened next was the most exciting part of Loaded and Verified. A breakthrough technology was poised to reveal the planets to us like never in the 1960s. Because of spaceflight, it was no longer necessary to have better views of distant planets. Instead, you could see moving planets through the windows. Scientists on Earth got a taste of what it would be like to visit an alien world from this experiment. The first space voyages beyond Earth were directed at our nearest neighbour, the Moon. Soon, space probes crossed the great ocean of interplanetary space and sent back images of Mars and Venus. In addition, the first images of the hidden far side of the Moon were taken by the Soviet spacecraft Luna 3. The possibilities were endless. Mercury's surface has also been baked by the Sun. NASA research even farther to the distant outer planets in the 1970s and 80s. The most famous mission, Voyager 2, visited 4 giant planets in a row, including Jupiter, Saturn, and Uranus, before reaching Neptune in 1989. In recent years, the second wave of missions has allowed us to see the solar system from new perspectives and provided us with a robust new understanding of many planets. Sometimes that perspective means more detail and complexity than we ever imagined, such as these cloudy swirls in Jupiter's turbulent atmosphere. The icebergs could also be on Jupiter's moon, Europa's surface. There have been other cases where spacecraft revealed more history than we could have imagined in this barren Martian desert crater. The rim of the crater contains layers of ancient rock. These layers have been read like pages of a novel by geologists, and the story they tell describes long-vanished waters that once dissolved an alien landscape. The rich information, perspectives, and valuable data we receive from so many planetary missions show how diverse our solar system is. Additionally, we know that these very different places in the solar system have a common origin. The evidence shows that our Sun was born from an interstellar cloud of gas and dust some 4.5 billion years ago. Today, we can observe the same process in our Milky Way galaxy with the Hubble Space Telescope. We see what appears to be a gorgeous nebula of glowing gas, but it is actually a star factory, and our Sun was born there. There are unique characteristics for each member of our solar system family. As matter swirled together to form our newborn star, the Sun was not created in isolation. This matter ended up in a disk of gas and debris spinning around the infant Sun. Planets, moons, asteroids, and comets were born from the disk, like different children of the same parents. How did these solar system objects take different paths from the same essential ingredients? This is one of the big questions in planetary science. There was only one pathway that led to Earth, as far as we know. The Earth has the potential to sustain life. That life has been protected by it. After experiencing this, I began wondering about the solar system. We will not stop exploring. Our journey will also end at the starting point, knowing where we are. All the planets in our solar system share these traits. All the moons, all the asteroid bodies. Putting together these stories will also help scientists understand how we got here. On our own, at our own pace. We all face these questions. How we go about addressing them is described as well. The process has begun. Our solar system has many epic and beautiful destinations waiting to be explored, but none is more terrifying or beautiful than this hellish realm of searing, writhing, and dancing fire. We're talking about a vast and volatile powerhouse whose explosive explosions can reach thousands of miles into space, rattling our tiny world. The Sun is our star. Our entire living world and civilization depend critically on its power. Life as we know it would not be possible without the Sun's warmth and light. Even in ancient times, they regarded it as God. Our Milky Way galaxy is filled with hundreds of billions of stars, including the Sun. For us, the Sun is the most important star. Our solar system has 8 planets, several dozen moons, hundreds of thousands of asteroids, and possibly trillions of comets. Despite this, there is only one Sun, and it is 1,000 times more massive than the rest of our solar system combined. Everything is kept in orbit by the gravity of the Sun. The Sun always takes center stage wherever you are in the solar system. Galileo, a 15th century astronomer, was convinced our solar system was centered on the Sun, not the Earth. To defend his radical view, he was tried for heresy. Besides pointing a telescope at the Sun, Galileo made another surprising discovery. The Sun sometimes develops dark patches that seem to drift across the surface of its blazing surface. Eventually, astronomers learned that a subtle pattern governs the appearance of sunspots. On either side of the Sun's equator, they increase in number over an 11-year cycle. They cover all regions of the solar surface as they extend north and south. Each reaches its peak and then diminishes, and the cycle starts. It is clear from sunspots that our solar system is not just a simple light bulb, but a dynamic and complex one. There were hints that the Sun is more than meets the eye, even before Galileo's time. The most obvious occurs every time the Moon passes directly in front of the Sun, resulting in a total eclipse. An eclipsed Sun is surrounded by a glowing cloud of white light called the solar corona. In the highly ionized outer atmosphere of the Sun, ionized gas is energized to a much higher temperature than at the surface. The corona is also constantly changing, just like sunspots. Scientists could not explain where the Sun's energy initially comes from for generations, because these clues suggest it releases its energy in complicated ways. An unexpected side effect of the atomic age followed. Scientists have discovered how sunlight is produced by discovering nature's hidden nuclear forces. The Sun is mainly made up of hydrogen gas at its surface. As with most stars in the universe, the gas is about 5,600 degrees Celsius, hot enough to emit a bright yellow light. Temperatures reach millions of degrees in the Sun's core, and hydrogen atoms can combine to form helium under these extreme conditions. As energy is released from the Sun's core through overlaying layers, it gradually escapes into space. Our planet receives only a tiny fraction of the Sun's total energy. Suns are not always benevolent, as there is ample evidence to prove it. It has remained steady for eons, allowing life on Earth to flourish. Solar flares, which produce dazzling aurora borealis displays and giant explosions on the Sun, have long been known to scientists. For scientists to understand the Sun's changeable nature and how it influences the Earth, they must venture into space. It is possible to observe the Sun around the clock, and in ways not possible from the ground. As a result, astronomers have been able to study the rotational surface of the Sun over a long period. Using a circular disk to block the Sun's light is a less direct method of studying solar activity from space. Creating an artificial eclipse inside the spacecraft makes it easier to observe dramatic changes in the Sun. This method was used for years by the SOHO spacecraft. Comet-like particles are hurled at SOHO by a swoop of high-energy particles. Occasionally, a vigilant spacecraft will catch a trespasser. A transit of Mercury across the Sun can be seen here. Space views reveal an incredibly dynamic Sun connected from surface to corona by an invisible force, magnetism. Magnetism is the most potent force in the solar system. As a turbulent, electrically charged fluid, the Sun is not a solid body. The motions of that fluid create the Sun's magnetic field. Fields such as this poke through the solar surface and form loops that extend into space. Sunspots are created when material that would typically turn over and sink back into the Sun's interior is temporarily held at its surface and allowed to cool and darken. Solar magnetic fields can store enormous energy in their loops and twists. This energy is released rapidly and violently. Solar flares are the result. SOHO captured these photos of one of the most powerful solar flares in history on October 29, 2003. A vast region of magnetic activity first appears on the left-hand side of the Sun. As high-speed charged particles hit the spacecraft's camera, this region gradually moves toward the center of the Sun, where it explodes in a flash of light and burst of static. But a powerful solar flare can quickly destroy it. A coronal mass ejection is another hazard often associated with solar flares. As a result, there is a massive release of magnetically energized particles from the Sun's corona. Once they encounter Earth, the particles travel at high speeds through space. Particles cascade onto the atmosphere around the north and south poles, producing brilliant auroras. We have learned that the Sun is not an isolated and distant part of our solar system because of the age of space exploration. Earth travels through the Sun instead, and it is not just Earth that experiences this. The Sun is beside our planet and all other planets in our solar system. As a result, we are separated from the flow of interstellar material that permeates the galaxy with the Sun by a giant bubble. It is not just a star that we have. Stars surround us. As children of the Sun, there is also a connection between us. Each planet was created from the same primitive mix of atoms that formed the Sun billions of years ago. Since then, each planet has gone its way, sharing its own unique story. Discovering what lies beyond the horizon has challenged explorers for generations. In spaceflight, we explore alien worlds and discover vast new territories. The intrepid machines blazing a trail for us across the solar system today allow us to see the Sun, Moon, and planets with penetrating clarity. Through their cameras, we have been granted unprecedented access to the universe that they have discovered. To the human eye, our universe comprises light. It is the sign that matter is found in stars, galaxies, and vast expanses of glowing gas. Life cannot exist in this colourful world of gas and stars. The sweltering temperatures in space that produce gaseous glow are too extreme for life to survive. A strange environment is what life needs. It needs solids instead of gases. Rocky planets are ideal for life. There is no guarantee that life will take root because you have a solid foundation. There are many rocky worlds in our solar system. It would be impossible for life as we know it to exist without planets made of rock. Mercury is first on our list. It rotates slowly in the glare of the Sun, alternately baking and freezing. Mercury is the closest planet to the Sun, and its surface temperature can reach over 420 degrees Celsius during the day. The temperature can drop to minus 180 on the planet's night side, when the heat is rapidly radiated into space during long months of darkness. Until the beginning of the 21st century, Mercury's only visitor was the Mariner 10 spacecraft. We got to see Mercury's battered and baked surface up close for the first time. Mercury aims to orbit it and conduct the first comprehensive survey of its geological features and mineral composition. The spacecraft's view of the planet was incomplete, since less than half was visible. NASA launched Mercury Messenger in 2004. Messenger's images, at first glance, seem to depict a desolate lunar landscape. Mercury's surface was blasted by an enormous crater-forming impact, kicking up debris. Among the craters are some giant cliffs and escarpments. Mercury is known for them. The wrinkles may have formed because of the planet's giant metal core cooling and contracting. In Messenger's first images of Mercury, one can see only the bare bones of a rocky world. Over eons of geological time, nothing much has changed here, except the surface. This planet does not have an atmosphere. Mercury may provide some beginnings of a stable platform, but it is far too hot and barren to be anything other than an empty stage. In order to turn a dead planet into a living one, more than just an atmosphere is needed. Another rocky world, Venus, is mysterious. Venus was hidden from astronomers for centuries because of its dense, cloudy atmosphere. We now know that Venus's atmosphere consists mainly of carbon dioxide with sulfuric acid clouds. The sun's energy is trapped by carbon dioxide, heating the planet to a staggering 466 degrees Celsius, making it even hotter than Mercury. The air pressure on the surface of Venus, even though Venus is twice as far from the sun and its atmosphere is extremely dense, is so high that it would easily crush a human astronaut to death. It is easy to be deceived by first impressions. Countless meteorite impacts over billions of years have left the surface rough and heavily cratered. Mercury is so heavy that it is probably almost entirely composed of metal. Mercury's mass is twice as great as our Moon, even though it is slightly larger. Scientists have speculated that Mercury was a much larger planet whose exterior was shattered mainly by a collision. The result was a thin, rocky mantle surrounding a substantial metallic core. Mercury once bubbled and rumbled with the heat coming from a tumultuous internal formation. Several features show a volcanically active past. Underneath the more recent impact craters, we can see multiple ripples. Waves on the surface were frozen in time to reveal vast pools of lava that had once covered the planet. A blue area represents an ancient terrain gradually buried by orange-red debris. This image emphasizes Mercury's long history via false colors. Venus's extreme conditions have only allowed a handful of Soviet landers to take brief glimpses of its surface, none of which have survived for over 2 hours. Scientists had to devise other ways to explore Venus's remote terrain, with a planet so inhospitable to spacecraft. Radar can penetrate the cloud cover and bounce off the rock below, providing a detailed view of the planet's bizarre and dramatic landscape. Images like these reveal a volcanic world that may still be active today. Venus's surface appears to be black impact craters, which differ from what we see on Mercury, which shows that Venus is young and is likely to be continuously developing. Scientists now suspect that Venus might have been more like our planet in the past. Despite this, Earth's atmosphere warmed, destroying a vital part of its uniqueness. There is water in it. Our planet's oceans have played an instrumental role in keeping it suitable for life on Earth. Additionally, the oceans lubricate Earth's rocky surface and moderate the climate. It is primarily the planet's internal heat that moves the continent slowly. As on Venus, heat could build up without water and burst out in massive lava flows. Oceans provide an environment where molecules can interact in a liquid medium. Certain conditions can transform mere chemistry into life. A planet with all three ingredients, a solid surface, an atmosphere, and oceans of liquid water, has the potential to create something new. This could be the emergence and evolution of life. Our planet Earth is a shining example of what rocky worlds can do. Earth's wildlife is diverse and complex. Additionally, it has buried its tracks, making it difficult to understand how the planet came to be the way it is today. The technology is now available to explore the rest of the solar system, which is why scientists are so eager to do so. We may find clues about what Earth was like before life appeared and how the process took place here. Maybe we can only fully comprehend who we are when we reach across the ocean of space to distant, rocky shores. The view of a full moon is perhaps the most haunting and beautiful in all nature. There is something both familiar and mysterious about it. A natural phenomenon. Still, it is unique. Today we find an alter ego in our nearest neighbor, not a mirror image. We have memories of the violent beginnings of our solar system and Earth's turbulent past throughout history. While Earth looks lush and colorful, the moon is a study in black and white. While the Earth's surface is shaped by water and air and is filled with the sounds of life, the moon is silent and still. Neither rivers nor winds blow on the moon. That is all there is. The moon has been Earth's silent partner for billions of years, keeping watch from above and keeping its secrets to itself. Since humans are not very satisfied with that, every civilization in history has a myth about how the moon was created. The story took a fortunate turn with space travel. There have been over 50 spacecraft that have passed by, orbited, or landed on the moon. Viewed up close, the moon's surface is dotted with impact craters. The moon is formed when minor asteroids collide with the surface at high speed. Massive impacts produce enough energy to liquefy and hollow out craters many times the size of the original impactor. The debris will also travel thousands of kilometers. Our planet has taken just as much abuse as the rest of the solar system over billions of years. Earth's impact craters are eroded or buried in sediment. Our solar system's hazardous nature is displayed vividly and precisely on the moon, where they accumulate. The number of craters on the moon can determine which parts of its surface formed first and which later. We can see, for instance, that the dark patches on the moon are younger than the bright areas surrounding them. Maria Latin for seizure was the name given to these dark patches by astronomers in the past. It is clear from up close that there has been no water on these alien shores. Maria is a vast, low-lying plain of volcanic rock, because these plains are richer in iron than other parts of the moon. They were covered with hot lava spilling from the moon's interior. This contrast makes them appear darker. The mapping of both sides of the moon's surface is a significant accomplishment of lunar exploration. The moon rotates in sync with its orbital period, with one side facing Earth constantly. This resulted in two different sides. Despite Maria, on the side facing Earth, the far side of the moon is much less contrasted. The strange sideness of the moon is because of its crust, which is significantly thicker on the far side. A few more significant impact sites are scattered among the ancient rugged terrain. Researchers now believe that billions of years ago, when the moon's internal heat forced lava up, it found a shorter route to the surface on its near side. When and how did those circular plains form in the first place? This question is answered by lunar samples returned by the Apollo astronauts. The samples show that the moon's Maria was once the site of enormous effects, some of which date back approximately between 3 billion to 9 billion years ago. The solar system was more crowded with debris in its history than it is now. A storm of asteroids appears to have swept through the inner solar system, pummeling all the planets and the moon. It left gigantic circular scars on the moon and Earth, but it caused far more damage on the moon. While no animals or plants lived on Earth, the effects would have vaporized oceans and liquefied extensive areas of our planet's crust. Microorganisms may have already appeared. Maybe only those microbes living deep down near deep sea vents survived the bombardment and became our distant ancestors. Astronauts have returned significant samples to Earth after bombarding the moon and the Earth. Perhaps the biggest surprise is the revelation that the moon was once the result of a giant collision. A large object as large as Mars collided with Earth early in our solar system's history and caused our planet to suffer a staggering blow. In the first moments after the collision, vast amounts of debris were thrown into orbit around Earth, eventually coalescing to form a single large moon. It may seem incredible, but this giant impact scenario offers the most plausible explanation for some of the moon's more puzzling characteristics, including its apparent lack of iron core. Because of the moon's presence, the tilt of the Earth's axis is stabilized, preventing climate swings that would devastate human life and civilization. Ironically, the destructive birth of the moon may have played a crucial role in maintaining Earth as the cradle of life in our solar system. The moon's history is closely intertwined with our own because of its formation. Life may have developed differently without the moon. Without the moon, we might not even exist. We have gained a fascinating perspective on the past by exploring the moon. For the US, China, and others, the moon may also be the gateway to a bright future in space. There are now efforts underway to return humans to the moon's surface. The goal is ambitious, but it is also a stepping stone to more distant destinations. We still do not know where the next human mission will land. The Moon is not short of exciting places scientists would love to explore. A visit to the lunar South Pole is undoubtedly at the top of their wish list here. The sun never shines on some craters' floors, always in shadow, cold enough for water vapor to condense in these dark craters and even form lunar ice. It is possible that comets colliding with the Moon's surface could cause the water vapor to appear. A recent study found hydrogen in many craters on the South Pole. This is robust evidence of ice. Ice on the Moon could provide explorers with much-needed water, if enough of it. Moon tells us that this world is just one among many in the solar system. It will be a challenge to find and retrieve the ice, since you will have to venture into perpetually dark areas. A new exploration of the Moon could pave the way for even more daring explorations on Mars and beyond in the future. Discoveries beyond the horizon have challenged explorers for generations. Exploring alien worlds with vast new territories is possible thanks to the invention of spaceflight. We may also visit them one day if we are determined enough. Our intrepid machines are blazing a trail across the solar system today, allowing us to observe the Sun, Moon, and planets in unparalleled clarity. Their cameras have become our windows into a bold and exciting world. These discoveries have become our cosmic vistas when everything is strange and exotic. Home is where we belong. When exploring the solar system, Mars is a familiar destination. It is a strange planet. The surface of Mars also has recognizable features. There are deserts and dunes, cliffs and canyons in this world. We can imagine ourselves exploring this landscape firsthand on 2 feet or 6 wheels. Mars is not easier to understand when it is familiar. Mars is better known to us than any other planet in the solar system, except ours. We have studied its landforms from orbit and sampled its soil and rocks from the surface. Its complex history and present state have only increased our questions, including the most important one of all: is there life on this planet? Our journey takes us to the borderland. There is no abundant life on Mars like there is on Earth. As well, there is no chance for life on the Moon. Mars is somewhere in the middle, so we can pinpoint where life is possible and not. The status of Morris borderland is not revolutionary. More than a century has passed since astronomers first speculated about the possibility of life on Mars. Scientists were surprised and disappointed by the first close-ups of Mars broadcast in 1965. Images of the surface showed it was cratered and barren, much like the Moon. The red planet was the dead planet, and any possibility of finding primitive life on its surface was all but wiped out. It is easy to be deceived by first impressions. After follow-up missions with better cameras began in the late 1960s and early 1970s, it became clear. The planet Mars is more interesting and diverse than anyone ever imagined. Impact craters were present, but there was also evidence of colossal geologic activity. Giant volcanoes were towering over the Martian plains, larger than any on Earth. The largest, Olympus Mons, rises to 24 kilometers, 3 times as high as Mount Everest. Consequently, this is the tallest peak in the solar system and Mars. The impressive structure results from many eruptions of lava that repeatedly flowed across the surface for billions of years. Olympus Mons rises from a giant bulge known as Tharsis, making Mars a lopsided planet. Eventually, it led to a spectacular split in the planet's crust, leading to this gigantic canyon. Its size and scope are unimaginable. It is 10 times bigger than Earth's Grand Canyon, and 4 times more profound. Currently, the most detailed images of Mars come from the Mars Reconnaissance Orbiter, a spacecraft that carries the most powerful telescope ever sent to another world. Mars has never been seen in such detail, allowing us to resolve details on the surface as small as a dinner plate. Mars was once wet, based on the images that suggest water flowed there once. The dunes of Mars are majestic, and there are dust devil tracks left behind. It appears there were layers of sediment in shallow Martian lakes, long before the giant canyon formed deep inside Valles Marineris. Water once flowed on Mars, as evidenced by the shape and orientation of the terrain. As we cast our eyes beyond the Valles Marineris, to a series of significant but empty channels leading from the Tharsis Bulge toward the low-lying regions further north, the evidence of watery pasts becomes stronger. Although they have dried up long ago, these valleys were most likely created by vast outflows of moving water that cut across the Martian landscape. The water then spills across the northern plains. Some of these channels are 100 kilometers across and cut through thousands of terrain. Scientists have drastically altered their idea about Mars since they were discovered. These channels bear all the signs of catastrophic flooding and show that water abounds on Mars. Today, Mars is too cold and too thin of an atmosphere for liquid water to survive on its surface. What caused this water to be released, and where did it go? The Tharsis Bulge can probably answer the first question. According to some recent research, Mars's giant volcanoes were formed by the intense heat that formed the release of vast quantities of water from its crust. The water initially flowed underground, but it broke through the surface, creating today's features. Other evidence suggests that water flowed on Mars billions of years ago. Observations from orbiting spacecraft suggest that much of this water lies frozen underground as permafrost near the Martian poles. Unlike the rest of Mars, the polar regions of Mars are distinctive. Both the north and south poles of Mars have visible caps of frozen carbon dioxide that expand and contract with the seasons, and both have a smaller underlying cap of water ice that never melts. Additionally, the poles have different surfaces. An abundance of ice mixed in with the rock in these regions, causing cliffs and crater walls to slump, giving them a smooth, rounded appearance. A recent development on Mars is the discovery of gullies running down the sides of craters and canyons. They were formed by groundwater seeping from the cliff faces and running downhill. As small as these features are, they must be recent. If they were older, wind-blown dust would have obscured them. Does liquid water occasionally bubble to the surface of Mars? This would have profound implications for life on Mars. Several decades of exploration have revealed that Mars may have once been home to liquid water and life. Even today, Mars may continue to be an active planet, as evidenced by recent observations. At least geologically, it is not yet a dead world. There is still a borderland there. All of this gives us an impetus to explore Mars further. Like the famous voyages of discovery centuries ago, the journey to another world is fraught with danger. Viewing and sensing from space have their limits. In order to determine whether Mars is a living world, we must touch, taste, and smell it. We can only accomplish these goals by exploring the surface of Mars. Additionally, when it comes to landing on Mars, making a robot that can land itself on Earth is challenging, as humans have never set foot on another planet where they do not know changing conditions. There will be little room for error between a safe landing and a major disaster. In the last 2 minutes and 25 seconds after the entry point, the peril is most dangerous. In addition, to do it in a place so far away, even a simple call for help would take several minutes to reach Earth. That would be a significant challenge. That is precisely what needs to be done to reach another planet. As of now, 6 landers have successfully landed on Mars, and they have transformed our understanding of the planet as only first-hand experience can. Scientifically, these missions have revealed the geologic history of Mars. In addition, these missions have profound global implications. When our probes land on Mars, we are not just looking for the ancient past. A new era in space exploration is dawning, a new beginning. A Viking spacecraft and 2 others became the first to establish a beachhead on Mars 70 years ago. Earth's deserts immediately recalled Earth's geologists. When the Vikings arrived, the similarity disappeared. NASA's Mars Pathfinder landed near the mouth of the Ares Valley, a large channel that appears to be carved by water. Boulders slanting downstream surrounded the landing site. The flood was ancient and violent. It does not entirely rule out life on Mars, but any life that survived here would have had to be sheltered underground or in another inaccessible location. The next successful attempt to land on Mars would not come until 1997. A small rover was the highlight of the mission. It rolled off the lander and trundled up to the nearby rocks to analyze their compositions. A set of wheels was needed to solve the mystery of Mars. Early in 2004, 2 rovers named Spirit and Opportunity landed safely on Mars. Each rover traveled on Mars by motor. From the beginning, the 2 rovers were in very different settings. One was at Gusev crater, the other at Eros crater. As revealed by the orbital evidence, standing water may have left its mark on the soil chemistry from an ancient lake. In the meantime, the Opportunity won a historic victory. Spirit opened its electronic eyes to find a barren plain littered with volcanic rock. The probe was sent to Meridiani Planum, where remote sensing identified hematite, an iron-rich mineral associated with water on Earth. Meridiani initially appeared to be a flat, featureless plain, but a miraculous opportunity landed in a small crater with an exposed rock outcrop. For the first time, scientists will sample rock on Mars where it formed. Everyone found that the opportunity was beyond their wildest expectations as they wheeled up to the outcrop. There was ample evidence that the rock formed in a watery environment because of its layers. As the rock weathered away, hematite was exposed as tiny spheres called blueberries that grew precipitating from the water. Having investigated the terrain near the landing site, scientists sent Spirit rolling toward a set of distant hills nearly 4 kilometers away. The trip to the hills would take 3 months, and climbing them would take even longer. Spirit had finally reached the top when she radioed back a panoramic view. Spirit descended to the other side of the hills during the following years, survived 3 Martian winters, and eventually found the home plate. Those are the remains of a volcanic vent where hot rock once came into contact with water. Meridiani did well as opportunities spread across the plains, uncovering an even more extensive rock outcrop, whose layers read like a geological history book, an ancient tale told of a place that once was wet and acidic, while there was no water at all at other times. We have seen an adventure unlike any other in our exploration of the Red Planet with the Mars rovers. After nearly 2 years, a more roving opportunity arrived at Victoria Crater and recorded one of the most breathtaking views ever seen on Mars. The newly arrived Mars Reconnaissance Orbiter captured the moment in space, spotting the tiny rover perched at the crater's rim. Water used to flow in places on Mars. Scientists then wanted to know how much water is present on Mars today. They have shown us Mars over many years and kilometers, instead of an isolated spot for a brief time window. Scientists expected to find water locked deep beneath the surface of Mars' polar regions, frozen in a frozen state beneath the surface of the Phoenix lander, which was modest compared to the Mars rovers. Low mounds surrounded by troughs dominate landscapes like this. In these mounds, the soil has been forced upward by the expansion of ground ice. Phoenix discovered something white just centimeters below the surface using its robot arm. Ice proved that Mars used to be wet. In the low-lying northern plains of Mars, where there may once have been a Martian ocean, Phoenix landed. Phoenix could not confirm this, but it found that the soil here is alkaline, similar to seawater here on Earth. All these missions have shown that Mars once was a water world, even though it is hidden from view today. It will be up to future missions to determine for life on Mars. Recent missions have already paved the way for human life on Mars. We may build the leading edge of a fresh wave of exploration that could take astronauts to the Red Planet one day. In that case, the human story on Mars has already begun. The solar system's outer reaches were always cold enough for gas molecules to stick together and form ice. That ice accumulated into ever larger chunks until gravity took over, pulling in vast amounts of material billions of years ago. This set the stage for planet formation on a considerable scale. Cassini's images of Saturn make it one of the best planets imaged in our solar system, despite Saturn's distance from Earth. Saturn continues to amaze and delight us with every new image it takes. You would be better off if you had a spacecraft. With the invention of the telescope, we discovered that there is much more to our solar system than meets the eye. Pluto and Neptune are compelling cases, not Uranus and Neptune. While powerful telescopes can probe the solar system's outer limits, these worlds remain remote and mysterious. It will be the end of an era when New Horizons reveals Pluto. Pluto is no longer officially referred to as a planet, but it represents the last type of object in our solar system that we have not yet seen up close. Discovering what lies beyond the horizon has challenged explorers for generations. Because of the invention of spaceflight, we are now discovering alien worlds with vast new territories. With the help of intrepid machines blazing a trail across the solar system, we see the sun, moon, and planets with penetrating clarity today. Their cameras have been our windows on an adventurous and daring journey. In our solar system, there are over 100 moons. Almost all of them orbit Jupiter and Saturn, the two most important planets. Jupiter has many moons orbiting it. Collectively, they range from small to large, cold to hot, and quiet to active. There may be a hidden haven for alien life somewhere in that range of possibilities. Saturn is reasonably small, but some of its moons are so large and complex they could easily qualify as planets. Over the past 300 years, astronomers had little to say about these fascinating places thanks to spaceflight. However, that has changed. In 1979, Voyager and 2 flew past Jupiter's 4 largest moons with their cameras rolling. Radioed pictures reveal that each moon has a unique personality and features never seen before. Io, the innermost of the 4 moons, was the most surprising. Unlike our moon, its surface is mottled and sulphurous. Its surface is devoid of craters. The craters seem to be erased by a mysterious agent. Voyager 1 spotted something unusual, protruding 300 kilometers from one side of Io. A giant volcano erupted in a fountain of ash. Since then, it has become apparent that Io is the most geologically active planet in the solar system. The surface of Io is one giant lava flow with more than a dozen active volcanoes towering over the sulfur-rich landscape. Io generates vast amounts of heat because of the tug-of-war between Jupiter and some of its other large moons. This results in a dynamic surface, but it is inhospitable to life. Callisto, Jupiter's outermost large moon, could not be more different. Callisto's battered face is dotted with ancient impact craters, suggesting that little has happened here since it formed. It is easy to be deceived by appearances. Ganymede, our largest moon and one of the most peculiar looking in our solar system, shows signs of a geologically active past. Recent data suggests there might be salty water beneath Callisto's surface of ice and rock. The survival of life in such an environment remains an open question. A dark and heavily cratered area of Callisto. Unlike the dark areas, the parallel grooves and ridges of the more recent terrain break up the dark areas. Exactly how these ridges and grooves form remains a mystery. Ganymede also has a warmer interior than Callisto. Ganymede's interior may have once been heated, causing parts of its surface to drift apart as on Earth. The heat likely caused Ganymede's interior to separate into layers, starting with an iron-rich core at its center, a rock mantle surrounding it, and a layer of ice on top. On Ganymede, there is evidence of an ocean of salt water below the surface, as there was on Callisto. Ganymede may finally maintain life with the right combination of heat and water. However, life forms such as these would be isolated from the sun. Ganymede has an ocean beneath its frozen surface, 200 kilometers deep. It might survive on chemical energy, like deep-sea creatures around Earth's ocean vents. That possibility will not be tested for a time. There may be a better opportunity in Europa to explore the ocean of another world. Europa appears to be the least interesting of Jupiter's moons because of its flat, smooth surface. A lack of dramatic relief, like large craters or mountains, might show nearby water. Cracks crisscross Europa's ice crust, occasionally breaking open, letting slushy water spill out. Scientists found what appeared to be icebergs floating apart in one area before the surface reef froze. Europa's ocean is on the top of the list of locations where scientists are eager to search for alien life today. The surface ice of Europa has some cracks that are darker and redder than the rest. The ocean beneath could be rich in sulfur compounds and organic molecules. There is some sign that this ocean may be closer to the surface than 10 kilometers in some places. The possibility of drilling down and exploring another planet's marine environment may be within reach in the future. I expect many mysteries to be hidden on the moons of Jupiter. Titan was shrouded in a thick orange haze when Voyager 1 arrived in 1980. Titan, Saturn's giant moon, is hidden even from view on its surface. Our solar system's only moon with a substantial atmosphere is Titan. Titan's atmosphere produces a haze similar to the photochemical smog when sunlight reacts with methane. Scientists would have to wait for an entire generation before revisiting Titan. When Cassini landed at Saturn in 2004, it used a high-powered camera equipped with an infrared filter to peer through Titan's thick haze. Cassini found a surface divided into mysterious light and dark regions resembling ancient coastlines. Titan has also been detected by Cassini, confirming that the Moon's surface is solid and has unusual landforms like ice, volcanoes, and wind-blown dunes. Cassini's radar made a further discovery after several more passes of Titan. There were a series of dark patches that were perfectly flat, resembling the surfaces of small lakes, prompting scientists to search for more direct evidence of fluid flow on Titan. Cassini's probe descended slowly into Titan's cloudy atmosphere after deploying its parachute. Images were transmitted to Cassini. As soon as it emerged from the clouds, the probe saw exciting details, as if the liquid had carved them. Finally, the probe survived its impact and sent back a spectacular image. On Earth, rocks in a stream bed are surrounded by a fluid flow, like chunks of ice on the planet's surface. Since Titan is so cold, water is like rock, but methane, a gas on Earth, can rain down from Titan's atmosphere and flow like liquid over its surface. It is a component of the kinds of complex molecules that led to the emergence of life on Earth. In addition, if Titan has an internal heat source, like some of Jupiter's moons, it could harbour its ecosystem deep below the surface. In our exploration of the outer solar system, Titan and Jupiter's moons have become more than just sideshows to the planets they orbit. Water appears to be a given on Earth. 70% of Earth's surface is covered by water, and its presence is essential to life on the planet. Water plays a different role in the dim reaches of Saturn's outer solar system. In these regions, temperatures are near 100 degrees Celsius, and water is everywhere. Water cannot exist in a liquid state. It is so solid that it remains frozen, even though it covers planets. The world depends on it. At Saturn, ice is the primary ingredient in forming moons. Cassini has revealed spectacular details about Saturn's moons, surrounded by an entire family of icy moons. Scientists hope that exploring these frozen worlds will reveal an ancient story about Saturn and the entire outer solar system. Phoebe is undoubtedly the first moon Cassini encountered up close, as it was the first of Saturn's moons. Phoebe is too small and its gravity too weak to pull itself into a sphere just 200 kilometers in diameter. Phoebe was found to have a carbon-rich surface with deep craters that exposed layers of bright white ice below. Phoebe is darker and contains more rock than Saturn's other icy moons. It did not originate near Saturn, but in the Kuiper Belt beyond Neptune. This zone contains ancient objects. These are the original building blocks of our solar system. Phoebe escaped from that region and was later captured by Saturn and transformed into a moon. Observing this moon gives us a glimpse of what we will find at a great distance from the Sun. Besides being 4 times closer to Saturn than Phoebe, Iapetus is also 4 times larger. Although it is 80% ice, its most distinctive feature is its 2-tone shading. Iapetus has a black side and a whitish-grey side. It is also significantly more remarkable on the black side. This difference equates to about 15 degrees warmer on the dark side. Scientists now believe that dark material may have fallen long ago onto Iapetus from the surface of Phoebe. Dust received more of the sun's energy on the side that received it. There, the ice sublimated, leaving behind grains of dust and rock that darkened the surface further. In the meantime, the vaporized ice resettled on the other side of the Iapetus and around its poles, creating the appearance it has today. Cassini discovered running along Iapetus's equator, thanks to a long ridge, that it looks like a walnut. The ridge rises to 13 kilometers in space. We do not know what created this bizarre feature. It probably happened when Iapetus spun faster and had more internal heat shaping its surface. Hyperion, an irregular, honeycombed object with an odd shape, moves closer to Saturn. The shape and appearance of Hyperion suggest it is the remnant of a giant moon that shattered in a collision. Perhaps it is not even solid, but a loosely packed pile of rubble. Cassini's measurements reveal Hyperion has over 40% of its mass in space. There are signs of ancient collisions on Saturn's moons, including Rhea, Dione, and Tethys. At first glance, these three round moons seem to be identical triplets. The two are over 1,000 kilometers across and covered in craters from billions of years ago. Each is a variation of the other. There are distinct characteristics among the three, suggesting a more complex and diverse past. Kuzma, for instance, wraps around Tethys like a waistband in Ithaca, a vast canyon. Tethys may have formed this long ago when its icy interior froze and expanded, causing its crust to stretch apart at its seams. Scientists observed a series of wispy white lines running across Dione's surface from afar long ago. Cassini revealed the lines of the bright faces of cliffs formed when internal forces repeatedly shattered Dione. Rhea presented Cassini with indirect evidence that this moon was surrounded by a dark, dusty ring, making it the only moon anywhere in the solar system with its ring. At least one of Saturn's icy moons may have once been geologically active, but subsequently cooled and grew dormant. This has enormous implications. In addition, Enceladus has a diameter of 500 kilometers. This object size is usually too small to sustain heat for billions of years. Enceladus is not like other planets. Cassini's investigations of the surface have revealed a strange and puzzling sight. Cassini spotted a considerable water vapor geyser near the south pole of Saturn. During Enceladus's orbit around Saturn, the vapor carries dust grains, which escape into space and form a diffuse ring. In addition, Enceladus is stricken with long, deep gouges nicknamed tiger stripes, from which the geysers are said to arise. Stripes surround fresh eyes. This suggests that temperatures below the surface are sufficiently high to melt ice and hold liquid water under pressure before venting into space like a tea kettle. Enceladus is at the edge of our solar system's icy region. The exact mechanism by which Enceladus does this is unknown. According to Cassini, Saturn's moon, Enceladus, has more rock and metal than many of Saturn's other moons. Saturn and its moons produce powerful tides, so it is warmed by a combination of radioactive heating from within and tides from Saturn. Of even greater interest are the organic molecules within the tiger stripes. Enceladus has all the ingredients for life if liquid water is present. This is an astonishing discovery. The icy moons of Saturn are strange. Science's goal is to learn how these strange worlds formed and developed, despite their utter differences from Earth. Why, you ask? There must be countless icy moons in the universe, if there are so many in our solar system. There is at least the potential for life whenever one of those moons gets warm enough to melt the ice into water. Perhaps this is our best shot at answering the age-old question, is there anyone else out there? For centuries, astronomers have thought of the solar system as an orderly place where planets, including Earth, go about their daily lives in peace. Today, we realize that the solar system is a cosmic shooting gallery filled with asteroids and comets that could threaten life on Earth. Exploring these objects is therefore not simply a matter of science, but survival as well. This is an ironic result. The danger posed by comets and asteroids to life on Earth is part of what motivates our interest in them. There is a strong possibility that life on Earth would not exist without comets and asteroids. The discovery that the Sun is just one star among billions, and Earth just one planet, led astronomers to assume that there are other worlds beyond our solar system. It took nearly 4 centuries since the invention of the telescope for us to find these worlds, which is a technical challenge of the highest order. We have seen a revolution in our ability to discover and study planets beyond our solar system in the last 15 years. The following 15 years will be even more exciting as Kepler and its successors attempt to find planets like Earth. Once they find such planets, They will look for evidence of life.
Che mamari nina. Juda la ba. Kopana lana tula ba.